Hello, my name is Stephanie O'Daly and I'm a PhD student at UAF. Thank you for watching my poster presentation titled Efficient Carbon Export in the Northern Gulf of Alaska during the 2019 Pacific Marine Heat Wave. Sinking marine particles transport carbon to the deep ocean from the ocean's surface, modulating atmospheric carbon dioxide concentration and supplying food to the benthos. Few in situ measurements exist of the biological carbon pump in the Gulf of Alaska, however. In this study, we aim to characterize the magnitude and efficiency of the biological carbon pump and identify drivers of carbon flux in the Northern Gulf of Alaska. We deployed drifting sediment traps to collect bulk carbon flux measurements and intact sinking particles in polyacrylamide gels simultaneously. Export efficiency ranged from 29 to 119%, with a median of 71%, indicating that freshly produced material was efficiently transported below the euphotic zone. Particulate organic carbon fluxes generally decreased over depth, consistent with a power law curve. The magnitude of carbon flux varied considerably with depth and station, but fluxes were generally higher near the coast, ranging from 72 to 2,130 milligrams of carbon per meter squared per day, and these values diminish offshore. Attenuation coefficients B vary widely spatially, ranging from -0.3 to 2.26, with a mean of 0.63. Carbon flux attenuation with depth increased with distance to shore at all lines. Polyacrylamide gels were imaged and particles were segmented using a combination of automatic and manual methods. Segmented particles were identified to particle type. The majority of carbon flux from all stations and all depths come from aggregates, averaging 71 plus or minus 12% POC flux. Carbon from fecal pellets only averaged 17 plus or minus 8% of POC flux. There does not appear to be much change in percent carbon flux by type over depth at each station. Most of the variability in the overall gel-derived carbon flux seems to be due to the variability in aggregate carbon flux. Overall, we found high carbon flux magnitude with low attenuation over depth and high export efficiency, especially at stations on the shelf. Flux magnitude and export efficiency decreased and flux attenuation increased at stations on the slope. The main driver of higher carbon flux was the amount of carbon flux from aggregates. This indicates that zooplankton play little role in recycling carbon at the surface. This pattern was consistent even during the marine heat wave, where small phytoplankton dominated the bloom rather than large diatoms, thought to be better minerally ballasted and have faster sinking rates, leading to enhanced carbon export. These results can help improve climate models and ecological models in the region to better predict the fate of organic material produced through photosynthesis.